This is our world. It is a sphere of blue and white, a living jewel suspended in the silent velvet dark. It is our home, a place of warm fires, of familiar coastlines, of breathable air and the comforting, immutable pull of the ground beneath our feet. From here, life is a grand and all-encompassing drama. The sun rises, the traffic moves, economies churn, and human stories unfold in their billions. But stand on this shore for a moment. Let the noise of the world fade and look up. Look past the sky into the true and infinite night. Suddenly, our grand drama feels small. Our thoughts, untethered, begin to leave home. What are we, really, in the face of this incomprehensible scale? Are we a miracle of cosmic chance, a brief and beautiful anomaly? Or are we just insignificant specks of dust clinging to a larger speck, adrift in an ocean of unimaginable forces? Is the universe a welcoming place, a garden of infinite possibilities waiting to be discovered? Or is it a hostile wilderness, indifferent and deadly, where our brief candle of consciousness is destined to be extinguished without a witness? We could stand here on this beach forever, lost in these questions, feeling the sand between our toes and the cool night air on our skin. We could wonder for a lifetime, or we could go. We could turn our back on the familiar shore, leave the comfort of home behind, and dare to see the universe for what it is. We could embark on a journey that will take us from this world to the very edge of space and time itself. It is a voyage that promises to let us feel the fierce, unbearable heat of burning stars and to face the raw, unbridled force of violent cosmic collisions. We will be challenged to dodge rogue planets and insatiable, supermassive black holes that warp the very fabric of reality. But we will also be privileged to witness the glorious birth of new stars from clouds of iridescent gas and to reach the absolute limits of human understanding. This journey means traveling backward through time, peeling back the layers of cosmic history until we arrive at the beginning, the very first moment of everything, to see for ourselves the instant it all began, the Big Bang. The choice is ours to make. The ship is waiting. Are you ready? Then let's go on a journey to the edge of the universe. Our ascent is swift, a silent climb through the thinning layers of our protective atmosphere. Below us, the continents and oceans resolve into a familiar, breathtaking map. Cities at night glitter like scattered diamonds, intricate networks of human ambition and connection. Just 100 kilometers up, a mere hour's drive, if the road went straight to the heavens, we cross the invisible boundary. We are now in space. Down there, life continues, blissfully unaware of our departure. The news cycles churn, politicians debate, and the rhythms of daily life proceed. We must leave all of that behind now, for we are about to dip our toe into a vast, dark ocean. The scale is already beginning to shift. Our planet, which contains everything we have ever known, now hangs below us like a child's marble. Our first port of call lies in the shallows of this cosmic sea, a familiar and reassuring presence in our night sky. It is the moon, at a distance of nearly 400,000 kilometers, a 3-day trip in a spacecraft. It remains tethered to us by gravity, a constant companion in our celestial dance. Dozens of astronauts have made this journey before us, their names etched into history. 12 of them, pioneers of a new age, have felt its alien dust beneath their boots. As we draw closer, its appearance is that of a deserted, ancient battlefield. The surface is relentlessly pockmarked, bombarded over eons by millions of meteoroids and asteroids. The pockmarks are craters within craters, a testament to a violent and chaotic youth. But it is quieter now. The silence is absolute, a profound emptiness that seems to absorb all thought. It is clear there have been no major collisions here for billions of years. There, glinting in the unfiltered sunlight, is a relic of our own audacity, the Apollo 11 lunar module, Eagle. It stands as a silent monument to a time when we first dared to step off our world. That's one small step for man, one giant leap for mankind. Neil Armstrong's words echo not in the airless void, but in our collective memory. For the Apollo astronauts, the risks were monumental. Every calculation, every piece of machinery had to be perfect. But the rewards were greater still. To see our planet as a fragile, unified whole floating in the void. To visit another world, a world with no atmosphere to protect it from the sun's deadly, unfiltered radiation. The landscape is a study in monochrome. It is a world of endless, congealed lava flows and piles of dull gray rocks coated in a fine, powdery dust called regolith. That dust is as fine as flour, but as sharp as microscopic glass, a hazard to any machinery. During the Apollo missions, the astronauts gathered hundreds of kilograms of these seemingly mundane rocks, the ultimate souvenirs. They were brought home for scientists to analyze, and what they revealed was a story of unimaginable violence. It turns out these dull gray rocks are not so dull after all. Like us, they have a deep connection to Earth. NASA's scientists discovered chemical signatures within them that pointed to an origin of extreme heat, evidence of a cataclysmic explosion. The leading theory now paints a dramatic picture. About 4.5 billion years ago, when our Earth was still a young molten world, it was not alone. A stray Mars-sized planet, which scientists have named Theia, collided with it. The impact was an event of almost unimaginable violence, an apocalypse that would have vaporized oceans and melted the entire surface of our planet. It blasted billions of tons of molten rock and debris from both bodies out into space. This incandescent ring of rubble, caught in Earth's gravity, eventually coalesced, cooled, and formed the moon. It is a strange and profound thought. The moon is made from the very same material as the Earth. It is the bone of our bones. Look there, Armstrong's first footprints preserved in the dust. They look as though they were made yesterday, with no wind to erode them, no rain to wash them away. They will survive for millions of years, a silent testament to our visit. They may well outlast the civilizations that sent them there. But our time here is limited. We have our own giant leap to take, a voyage further than any human has ever traveled. We must push onward into the deeper water. Out of the profound darkness ahead, a friendly face emerges. It is a beacon of brilliant light, the goddess of love, Venus, known as the morning star or the evening star. Venus is the solar system's brightest planet, a spectacular jewel in the night sky. Its beauty is due to its thick, continuous cloud cover, which reflects the sun's light with stunning efficiency. From a distance, she appears as a serene sister to our own planet, nearly the same size, with similar mass and gravity. It should feel safe here, another potential haven. But as we get closer, our instruments, informed by probes like the European Space Agency's Venus Express, tell a very different and terrifying story. These dazzling, beautiful clouds are not made of water vapor. They are composed of droplets of deadly, corrosive sulfuric acid. The planet's atmosphere is a suffocating blanket of carbon dioxide, 90 times thicker than Earth's. The pressure on the surface is equivalent to being a full kilometer beneath the ocean on Earth, a crushing force that would instantly destroy any unprotected visitor. Alarm bells are ringing. Venus is not a goddess of love. She is an angry goddess. The air is noxious, the pressure is unbearable, and it is hot. In fact, it is the hottest planet in the solar system, with surface temperatures approaching 500 degrees Celsius, hot enough to melt lead. Stay too long, and we would be corroded by acid, suffocated by the atmosphere, crushed by the pressure, and baked by the heat. Nothing can survive here. Look down on the scorched plains lies the wreckage of a testament to that fact. It is a Soviet Venera robotic probe, a marvel of engineering from the 1970s. It was built like a tank, with heavy armor designed to withstand the extreme environment for as long as possible. It survived for less than 2 hours before being completely destroyed. So lovely from Earth, up close, Venus is the sister from hell. Its surface, mapped by radar, is pockmarked not by impacts, but by thousands upon thousands of volcanoes. All that carbon dioxide in its atmosphere, likely spewed out by this rampant volcanism, has trapped the sun's heat in a runaway greenhouse effect. This is global warming gone wild. Scientists speculate that billions of years ago, before this process took hold, Venus may have been a calmer world, more like her sister, planet Earth, possibly with liquid water oceans. If that's true, this hellscape is a chilling glimpse into our own planet's potential future, a stark warning written across the sky. The source of that future, both here and at home, now looms before us, an object of hypnotic power. It is the sun, like the mythical Medusa. It's too terrible to look at directly, yet too powerful to resist. It lures us onward like a moth to a flame. Dwarfed and scorched by the sun, we encounter the innermost planet, Mercury. This is what happens when you get too close to a star. The temperature swings here are the most extreme in the solar system. At night, with no atmosphere to hold the heat, the temperature plummets to a frigid minus 170 degrees Celsius. By midday, the sun-facing side soars to over 400 degrees. It is a world both burnt and frozen. And look at those scars. The surface is covered in craters and massive cliffs called scops, evidence of a violent past and a planet that shrank as it cooled. Data from the Messenger space probe, which orbited Mercury for years, tells us something strange. For its small size, this little planet has an incredibly powerful gravitational pull. It must be far heavier than it looks. It's like a huge cannonball of iron, covered with only a thin veneer of rock. This suggests that Mercury was once a much larger planet. So, where is the rest of it? The leading theory is another cosmic collision. A stray planetoid may have slammed into a young Mercury, blasting away most of its outer rocky layers, leaving behind the dense metallic core we see today. Everything we see in this inner solar system tells a story of violence and chaos, a cosmic billiard game played out over billions of years. Everything is telling us to turn back, but who could defy this? The sun, in all its mesmerizing, terrible splendor, our light, our lives, our very existence, everything we do is controlled by this star. It is the pivot around which life on Earth revolves. It nurtures our crops, structures our days, and inspires our beliefs. From 150 million kilometers away, it is a comforting, life-giving presence. If it were to suddenly switch off, we wouldn't even know about it for a full 8 minutes, the time it takes for its light to reach us. It is so enormous you could fit 1,000,000 Earths inside it, and so massive that its gravity single-handedly controls the entire solar system, holding every planet, moon, asteroid, and comet in its grasp. We see it every day, a familiar face in our sky. But up close, it is utterly unrecognizable. The thermometer rises to over 5,000 degrees Celsius on its surface, the photosphere, and deep down in its core, the pressures are so immense that temperatures must reach tens of millions of degrees. It is hot enough to trigger the engine of the cosmos, nuclear fusion. Every second, deep in its heart, the sun fuses hundreds of millions of tons of hydrogen into helium. In this process, a tiny fraction of that matter is converted directly into pure energy, according to Einstein's famous equation, E equals mc. This process releases more energy every single second than all the energy ever produced and consumed by humankind throughout its entire history. Back home, we see this energy as gentle sunlight and feel it as warmth. From the surface, tracing the powerful magnetic field lines, each one can stretch for hundreds of thousands of kilometers into space, releasing more energy than 10 million volcanoes. You could fly the Earth through one of these loops with tens of thousands of kilometers to spare. Where these magnetic fields burst through the surface, they inhibit the flow of heat from below, creating cooler areas that we see as sunspots. They look black only in contrast to their brighter, hotter surroundings. They are still hotter than anything we can imagine on Earth. Some of these spots are massive, easily 50,000 kilometers across, large enough to swallow the Earth whole, and nearby, a solar flare erupts, a sudden, violent explosion that unleashes a superheated stream of electrified gas and deadly radiation, blasting out into space at nearly the speed of light, and pose a lethal threat to astronauts in orbit. But one day, all of this furious activity will stop. The sun's fuel will be spent. In about 5 billion years, it will swell into a red giant, engulfing Mercury, Venus, and possibly Earth. Then it will shed its outer layers and collapse into a white dwarf, a dying cinder. Its death will mean the end of all life on Earth. The sun creates life, and it will ultimately destroy it. It demands we keep our distance, as if to prove the point. A comet has strayed too close. It is being boiled away by the sun's intense heat, creating a spectacular tail of gas and dust that stretches for millions of kilometers. As we pass through its tail, the temperature plummets. It's freezing in here. There's no doubt where this object has come from, the icy wastes of deep space. But look at it. Steam, geysers, and dust are erupting from its surface. It's the sun again, melting the comet's frozen heart. It is a kind of vast, dirty snowball, covered in a dark, grimy tar. Within that tar and ice are tiny grains of organic material, complex carbon-based molecules preserved in a deep freeze since the formation of the solar system. Now, imagine a comet just like this crashing into the young Earth billions of years ago. It's a tantalizing theory that comets may have acted as cosmic delivery trucks. They may have sown the very seeds that over billions of years evolved into you and me. But imagine that same comet crashing into the Earth now. Think of the dinosaurs wiped out by a massive comet or asteroid strike 65 million years ago. It is not a question of if, but when such an event will happen again. Eventually, one day. Unless we can develop the technology to find and deflect these objects, our civilization could go the way of the dinosaurs. The Earth is safe for now. But if life on Earth were to be obliterated, we would need to find another home. Among the billions of planets that must exist in our galaxy alone, there must be one that's not too hot, not too cold, with air, sunlight, and the most precious commodity of all, liquid water. Our quest for a second Genesis leads us to the unmistakable red planet, Mars. For centuries, we have looked to Mars for companionship, for signs of life. Somewhere down on that rusty, dusty surface, there could be extraterrestrial life. But are we ready to find it? Are we ready to rewrite every history book, to tear up the science texts, to turn our entire worldview upside down? What happens next could change everything we think we know about our place in the universe. More than any other planet, Mars captures our imagination. Think of the science fiction films, the comics, the stories of invading Martians. It's all just fiction, right? But what if there really is something here? If there is, it is living on what appears to be a dead planet. The geological processes, like plate tectonics and a global magnetic field that make Earth so habitable, shut down on Mars hundreds of millions of years ago. From this distance, it is red and dead, a giant planetary fossil. But as we descend, we see movement. A dust devil, a swirling vortex of red dust, is tearing across the landscape. This one is a monster, far larger than the biggest tornadoes back on Earth. So there is wind here, and where there's wind, there's an atmosphere, but it's far too thin for us to breathe, composed almost entirely of choking carbon dioxide, with no magnetic field and a thin atmosphere. There's nothing to protect the surface from the sun's relentless ultraviolet radiation, and it is brutally cold. Temperatures can drop as low as -80 degrees Celsius, freezing what little water exists in the ground, at the poles, and even in the atmosphere, where it can fall as snow. It's hard to believe anything could live here. But then we think of Earth, where resilient creatures, exmiphiles, survive in the most extreme conditions imaginable, in volcanic vents, in the crushing pressure of the deepest ocean trenches, and even frozen solid in Antarctic ice. Life usually finds a way, but on a dead planet with no geological activity to replenish the minerals and nutrients in its soil, no internal heat to melt its frozen water, and all this suffocating dust, it's hard to see how. We need a source of heat and liquid water. Our view is now dominated by a structure of immense scale, Olympus Mons. It is a vast, ancient shield volcano, 3 times higher than Mount Everest. It is so wide that if you were standing at its base, its slope would be so gradual you wouldn't even realize you were on a mountain. Since its discovery, it has been declared extinct. Any lava flows on its flanks should be ancient, obliterated by meteorite impacts over millions of years. But recent observations suggest that this monster may not be dead after all. Some of its lava flows appear remarkably fresh, geologically speaking. If it's not extinct, but merely dormant, there could be molten magma churning deep beneath the crust right now. This changes everything. That volcanic activity could be melting the frozen water in the soil, creating warm, wet, subterranean pockets, perfect conditions for microbial life to exist. We fly over a canyon system that makes Earth's Grand Canyon look like a mere crack in the sidewalk. This is Valles Marineris, a network of canyons that stretches for so long it would span the entire North American continent. We see clear signs of ancient erosion, of dried-up riverbeds and vast deltas, as though immense quantities of water, perhaps released by volcanic activity melting the subsurface ice, once flowed through this canyon. And we now know that this activity could still be happening on a smaller scale, creating pockets of liquid water. Where there is water, there could be life. The hunt is on. Trundling. Across this desolate landscape, we see one of our own emissaries, the NASA rover Opportunity, or its successor, Perseverance. These robotic geologists are finding definitive evidence that these barren plains were once ancient lakes and oceans that could have harbored life billions of years ago. They have found minerals that only form in the presence of water. And look at this. When probes orbiting Mars pass over certain steep gullies, they keep spotting new dark streaks appearing. These could be brine flows, evidence that salty water may be flowing or at least seeping beneath the surface today. Mars is not the dead planet we thought it was. It is alive and kicking, a dynamic world that may be sustaining Martian life right now. All we have to do is find it, unless, in a strange twist, we have already found it, not on Mars, but on Earth. It's a radical theory known as panspermia. The idea is that life may have started on Mars first, when it was a warmer, wetter world. Then, a large asteroid impact could have blasted fragments of the Martian crust, complete with tiny, hardy microbes, out into space. Some of these rocks could have then traveled through the solar system and landed on the young Earth, seeding our world with the seeds of life. It's a mind-bending thought. No wonder we find Mars so fascinating. It could be our ancestral home. If it's true, it means we are all, in a sense, Martians. The Mars we thought we knew is gone, replaced by this new, active, changing planet. And if we are still uncovering such profound secrets about Mars, arguably the most studied planet beyond our own, what else don't we know? What other secrets are out there waiting to be discovered? Leaving Mars behind, we plunge into a region that feels like being inside a giant, chaotic video game. But these are all too real. They are asteroids, millions of them, rocky remnants from the formation of the solar system. Some are as small as pebbles. Others are hundreds of kilometers wide. This one must be about 30 kilometers long, an irregular chunk of rock and metal tumbling through space. Look, a Japanese probe is delicately parked on its surface. Imagine the difficulty of landing on a small asteroid traveling at 80,000 kilometers per hour. It seems like a lot of effort to investigate some rubble. But it was rubble exactly like this that, through gravitational attraction, came together to form the planets, including our own. By analyzing the meteorites fragments of asteroids that fall to Earth, we can date them. And they tell us that the planets were born 4.5 billion years ago. These rocks are the birth certificates of our solar system. But for some reason, the rocks in this particular region never formed a planet. Something must have stopped them. Something immensely powerful. Jupiter. What a monster. The king of the planets. It is at least 1,000 times bigger than Earth by volume. So vast, you could fit all the other planets in the solar system inside it. Something this big is going to have a major effect on its neighbors. It is Jupiter's colossal gravity that is constantly stirring up the asteroid belt, preventing the asteroids from ever coalescing to form a planet. In this way, Jupiter has been both a protector and a disruptor. It has likely flung countless comets and asteroids away from the inner solar system, protecting Earth from more frequent impacts. But this huge planet is almost all gas. If we tried to land here, we would sink through its colorful cloud layers, through ever denser hydrogen, probably never hitting a solid surface. Jupiter's good looks are the product of extreme violence. It spins on its axis faster than any other planet, completing a day in less than 10 hours. This incredible rotational speed whips up its atmosphere into powerful jet streams, contorting the clouds into distinct stripes, eddies, and whirlpools. And then there is the legendary Great Red Spot. It is the biggest, most violent storm in the solar system, an anticyclone at least 3 times the size of Earth. And it has been raging for over 300 years, ever since we first turned our telescopes upon it. All those churning clouds have sparked a perpetual, planet-wide electrical storm. Just one bolt of Jovian lightning is 10,000 times more intense than any lightning strike on Earth. It seems the best place, the safest place, to view Jupiter is from a distance. Look at those shimmering lights around its poles. They look like the auroras back home, but they are generated by lethal radiation, pulled from space and accelerated by Jupiter's immensely powerful magnetic field, the strongest of any planet. We are beginning to realize that out here, nothing is as it seems. The universe is full of contradictions, terrible beauty, violent creation. We have to proceed with caution. We weave carefully through the paths of Jupiter's dozens of moons. A solar system in miniature. This multicolored moon is called Io. Those pretty colors are not paint. They are molten rock and sulfur. Io is the most volcanically active body in the solar system, with hundreds of volcanoes spewing burning hot ash and sulfurous gas hundreds of kilometers into the air. This activity is caused by a gravitational tug-of-war between Jupiter and the other large moons, constantly squeezing and stretching Io, heating its interior. Our magical journey is turning into a desperate flight through a hazardous landscape. We have to keep believing, hoping that amidst all these dangers, there are safe havens out there somewhere. 650 million kilometers from home, we approach another of Jupiter's moons, Europa. What a weird-looking place, and yet it seems strangely familiar. The surface is a bright, fractured shell of ice, covered in ridges and cracks. It looks a bit like the Arctic sea ice on Earth. And maybe, just maybe, like the Arctic, this ice is floating on water, liquid water. It's an incredibly intriguing thought. But we are nearly 800 million kilometers from the Sun. Surely, Europa must be frozen solid, unless, once again, Jupiter's influence changes everything. The same gravitational flexing that turns Io into a volcanic hell could be gently warming Europa's interior, creating just enough friction and heat to stop it from freezing solid. It could be maintaining a vast global ocean of liquid water beneath its frozen crust, an ocean that could have existed for billions of years, protected from radiation by the ice shell above. In that dark, hidden ocean, we might be meters away from aliens. Not intelligent beings, perhaps, but a whole ecosystem of microbes. Maybe even complex creatures like crustaceans or squid huddled around hydrothermal vents on the ocean floor, just as they do on Earth. The only thing between us and the possibility of discovering alien life is this layer of ice, until we can send a spacecraft, a cryobot, to drill through that ice. Europa will remain one of the solar system's greatest and most tantalizing mysteries. It has captivated our imaginations, haunted our dreams, and inspired artists and astronomers for centuries. And here it is, spinning serenely before our eyes. Saturn, the jewel in the solar system's crown. Seeing it makes everything we have experienced so far worthwhile. There is something truly magical about Saturn. It is a giant ball of gas, so light for its size that it would float in water if you could find a bathtub big enough. And then there are its spectacular rings, which stretch for a distance almost from the Earth to the Moon, yet are, in most places, just a few hundred meters thick. They are a triumph of celestial architecture. The Cassini orbiter, which studied this system for over a decade, picked up ghostly radio emissions, probably generated by auroras around Saturn's poles. This is the real music of the spheres, and its data tells us that these beautiful rings are most likely all that's left of a large, icy moon that strayed too close to Saturn and was shattered by its immense gravitational pull. Incomparable beauty. Born from total destruction, billions upon billions of individual shards of water ice, some as small as ice cubes, others as large as houses, are all orbiting Saturn together. They collide, break apart, and reassemble in a constant, silent dance. It's like a snapshot of our early solar system, 4.5 billion years ago, when dust and gas orbited the newly born sun, and gravity worked its slow, persistent magic, pulling the lumps together until, from debris just like this, our home emerged. Every object orbiting Saturn is technically a moon, from the smallest block of ice to the planet's dozens of larger moons. One of them is larger than our own moon, larger even than the planet Mercury. It is Titan, and it is wrapped in a thick, orange, hazy atmosphere. But beneath those clouds, our probes have revealed a world that is astonishingly Earth-like. There is a thick atmosphere, primarily nitrogen, just like ours. Down here, there is wind, there are weather systems, there is rain, and there are even seasons. And look, we see rivers, lakes, and oceans. It is the most similar place to Earth we have seen so far, except that's not water. The liquid carving these river channels and filling these vast seas is liquid natural gas, primarily methane and ethane. At Titan's frigid temperatures, methane behaves just like water does on Earth. There must be hundreds of times more natural gas here than all of the Earth's known oil and gas reserves combined. If we could somehow get it home, It could power our cities and fuel our cars for thousands of years. Or maybe, one day, we could use it here to fuel a human colony. Assuming, of course, that there isn't already life on Titan. The Huygens space probe, which dropped from Cassini and landed on Titan's surface, found complex organic materials in the soil. But it is so cold here, -180 degrees Celsius, that there is no way for these molecules to interact and form life as we know it, unless Titan warms up. The sun is predicted to get hotter and brighter as it ages. In a few billion years, as the Earth becomes too hot for us, maybe the conditions on Titan will become just right. Maybe life will spring up here just as it did on Earth. One day, our descendants might call this distant orange moon home. We are at least 1 billion kilometers away now. Beyond this point, we lose visual contact with the Earth. It becomes just another point of light among many. It feels as though we are standing on a cliff, looking out into the mysterious, dark outer reaches of the solar system. If we truly want to understand the universe, to reach its very edge, we have to jump, unseen. From Earth and unknown for most of human history, we are now in the solar system's outer reaches. It's like diving deep into the ocean, where sunlight fades and strange new creatures emerge from the gloom. Look at those rings. That must be Uranus. The whole planet has been tilted off its axis, toppled over, most likely by a collision with a large, stray planet early in its history. It's eerie out here and lonely, but we have barely left the shore. If we were to shrink the Earth down to the size of a pea, we would have traveled less than 2 kilometers. But to reach the true edge of the solar system, we have to travel another 20,000 kilometers on that scale. Out of the deep, another strange beast emerges, the god of the sea, Neptune. From a distance, it looks like a peaceful, deep blue orb. But as we get closer, we see a dark spot on its surface. It's a vast storm the size of Earth, whipped up by savage winds that blow at over 1,500 kilometers per hour, the fastest in the solar system. Back home, it's the sun that drives the wind. But Neptune is too far away for the sun to have such an effect. Something else, some internal heat source, must be creating these ferocious winds. But nobody knows what dot. And just beyond Neptune, one of its strangest moons, Triton, just look at it. There are geysers erupting from its surface, cosmic chimneys, pumping out some kind of dark, sooty nitrogen ice. And this moon is orbiting Neptune in the opposite direction to the planet's spin, a retrograde orbit. This tells us that Triton was not born with Neptune, but is a captured object from further out, snared by the planet's gravity. It is locked in a cosmic battle of wills that this angry moon is destined to lose. Neptune's massive gravity is pulling on Triton, slowing it down, reeling it in. One day in the distant future, it will be ripped apart by the god of the sea and form a spectacular new ring system. And that's it. No more planets to see in our solar system. But the space beyond is not empty. It's teeming with frozen rocks and icy spheres, objects like Pluto until recently. It seemed Pluto was alone out here, a solitary outlier. But we were wrong. We are now discovering a whole new realm of the solar system, a third zone beyond the rocky inner planets and the gas giants. It is filled with thousands of more frozen worlds. The discoveries are so new that nobody can agree on what to call them, Plutinos ice dwarfs, Kuiper belt objects. Whatever the name, the implications are the same. Our solar system is not the neat, tidy model we once thought it was. Over 13 billion kilometers from home, we encounter the most distant object ever seen to orbit our sun, a small, icy world called Sedna. Discovered in 2003, its incredibly long, elliptical orbit takes 10,000 years to complete and sends it hurtling out to a distance of 130 billion kilometers from the sun. There is something else out here, 16 billion kilometers from home. We find a lonely traveler, the space probe Voyager 1, launched in the 1970s. It is our first true interstellar emissary. If it wasn't for this humble probe and its twin, Voyager 2, we would have no close-up images of the giant planets, no clue about their strange and wonderful moons. Attached to its side is a golden panel, a phonograph record. It's a kind of intergalactic message in a bottle. There are greetings recorded in different languages, sounds of Earth, music, and a map showing how to find our solar system. It is a message of peace and hope. But if you are in a dark, unknown jungle, is it wise to call out? Anyone or anything could hear our call, find out where we live, and come knocking. Friendly, ... or not. We are now passing through a vast, spherical cloud of cosmic icebergs, the Oort cloud. They look just like the comet we saw earlier. Perhaps it started its life out here. This is the great reservoir of comets. Seeing all this ice, it reinforces the idea that these objects may have carried water to the early Earth, filling our oceans and making life possible. The water in the oceans, in your morning coffee, even in the cells of your body, it may all have come from this distant, celestial ice machine. We are 8 million, that's 8 trillion kilometers from home. But our journey has only just begun. Ahead of us lie trillions more kilometers and billions upon billions of stars. This is it. It's time to step out of our home solar system, to cross the final frontier and enter the big, wide universe. We are entering interstellar space. What a view! Billions of stars, like our own sun, glitter in every direction. We now know that many of them have planets, and many of those planets have moons. It's hard to know which way to go. There are infinite possibilities in every direction. Whichever way we choose, we are going to need a serious burst of acceleration. 40 trillion kilometers from home. A 150,000-year ride in the space shuttle. And we have only just reached the first solar system after our own Alpha Centauri. Is not one star, but 3, locked in a complex celestial standoff. 2 of them are spinning around each other, while the third, a small red dwarf called Proxima Centauri, orbits the pair at a great distance. Each star's gravity is attracting the others, while their insane orbital speed keeps them from crashing together. We are so far from home now that kilometers have become meaningless. We are going to have to start measuring distance in light years. A beam of light travels nearly 10 trillion kilometers in 1 year. So, 40 trillion kilometers is over 4 light years from home. These are crazy distances, so vast they are almost beyond comprehension, and it is incredibly exciting. Who knows what strange new worlds lie ahead? 10 light years from Earth, we find the star Epsilon Eridani. It is surrounded by spectacular rings of dust and ice, and somewhere in there, planets are forming out of the debris, being born right before our eyes. There are asteroids and comets everywhere. We could almost be looking at our own solar system billions of years ago, with comets delivering organic molecules and water to these young planets, kickstarting life, just as they may have done on Earth. At the center of all the action is a star smaller and younger than our Sun. Any life in this solar system would be primitive at best. There must be more mature, developed solar systems out here. But finding them is like looking for a needle in a cosmic haystack 20 light-years from Earth. We find the star Gliese 581. It's about the same age as our Sun, and orbiting it is a planet that has generated immense excitement. It is located just the right distance from its Sun. Any closer, and its water would boil away. Any further, and it would freeze. It is in the habitable zone, the Goldilocks zone, where conditions could be ideal for life to have evolved. If comets have struck this world, delivering water and organic materials, then life, perhaps even complex beings like us, even civilizations like our own, could be down there right now. If they are, even at this distance, they could potentially be tuning into our old TV and radio signals. That's how long our broadcasts would take to get here. But until future generations can find a way of communicating or traveling over these vast distances, all we can do is speculate. Us and them, perhaps living parallel lives, completely unaware of each other's existence. Unless, of course, life has already been and gone. The problem with comets and asteroids is that they are both creators and destroyers, as the dinosaurs found out the hard way. This is the closest we have come to finding a truly habitable solar system like our own, but it's a chance encounter. There could be hundreds of millions more solar systems like this out here, or none at all. We travel further into the depths of our home galaxy, the Milky Way. It is a vast celestial library, and each star is a book with a story to tell. We pass the Seven Sisters, the brightest star cluster in our night sky. We see the giant star Betelgeuse, a red supergiant so large that if it were in our solar system, it would swallow all the inner planets out to Jupiter. But then we encounter something else. It is not a star, not a planet, not like anything we have ever seen. It is a ghostly specter, more than 1,300 light-years from Earth, Orion's dark cloud. It is a vast cloud of dust and gas, so dense it is, shrouding us, shutting us off from the universe outside. But deep inside, a miracle is happening. A ball of light is forming, its gravity pulling the dust and gas towards it, heating it up, merging it into a ball of burning hot gas, a protostar. Inside, temperatures are rising, reaching millions of degrees, so hot that it is beginning to trigger nuclear reactions, the very kind that keep our sun shining. It is making energy, radiation, light. A star is being born, or rather, stars. Orion's dark cloud is a vast star factory. We are witnessing the birth of the future universe. We came here expecting horrors, but instead, we have discovered one of the universe's greatest wonders, starbirth. Jets of gas are exploding outwards at 200,000 kilometers an hour, blasting away the surrounding dust and gas. It is unbelievably violent, but look at the results. ULAE, vast, glowing clouds of gas and dust, illuminated from within by the newborn stars. They are cosmic masterpieces, sculptures of light and shadow. With no wind out here, they will take thousands of years to disperse. We've seen some strange sights, but this one is a masterpiece. The Horsehead Nebula, a giant horse's head rearing up in space, silhouetted against a glowing red background. Stars are born, they grow up, and then what? Do they die? Do they slip quietly into the night? Or do they go out with a bang? Somewhere between here and the edge of the universe lies the answer. Nearly 4,000 light-years further on, we find luminous clouds suspended in space, encircling what was once a star, like our sun. This is a planetary nebula. All that's left of the star are these brightly colored gases, elements that were forged by nuclear fusion deep inside the star and then released into space upon its death. We see green and violet from hydrogen and helium, the raw materials of the universe. We see red and blue from nitrogen and oxygen, the building blocks of life on Earth. For us to live, stars like this had to die. The oxygen in our lungs, the nitrogen in our DNA, the carbon in our bones, it was all produced by nuclear fusion in the hearts of stars that died long before the Earth was even born. We are made of stellar nuclear waste. Our family tree begins. Here, at its heart, is the ghost of the star that created it, a white dwarf. It is white-hot, incredibly small, about the size of Earth, but unbelievably dense. In the star's dying moments, its atoms were fused and squeezed together, making it so dense that just a single teaspoon of this white dwarf would weigh 1 ton on Earth. It is a chilling premonition of our own sun's fate in 6 billion years. It too will become a white dwarf. Its death will herald the end of life on Earth. It makes you wonder how many other worlds have been and gone, how many celestial stories have been lost forever. But the greatest story of them all is still to be told. We must go back further through time to the very first chapter to tell the story of how the universe itself began. We journey on to the scattered remains of a much larger dead star. This is the Crab Nebula. We are 6,000 light-years from home, deep inside a stellar graveyard. Dust and gas stretch for trillions of kilometers. The calm after the storm, the aftermath of a massive explosion powerful enough to turn a huge star into a cloud of dust and gas. This was a supernova, and at its center we find the eye of the storm. It is a spinning, pulsating star, a pulsar. After the supernova explosion, gravity must have squeezed the giant star's core down to this. It's just 20 kilometers across, making it unimaginably dense. A single pinhead of this material would weigh hundreds, maybe millions of tons. As it shrank, like a figure skater pulling in their arms to spin faster, it began to rotate at incredible speed. This one is spinning 30 times a second, sweeping 2 powerful beams of light, energy, and radiation across the galaxy like a lighthouse. There is so much radiation here, more even than on the sun. If this pulsar got as close to Earth as our sun, our planet would be instantly stripped of all life. That was easily the deadliest thing we have encountered so far. But now we get a strange sensation, a feeling as though there is something bad out here, a malevolent presence. It is the one thing we didn't want to encounter. It is impossibly black, blotting out the stars behind it. We are staring into the face of death. It is the remains of an even more massive giant star, a black hole. Instead of contracting to a white dwarf or a pulsar, This star's core just kept on going, shrinking until it got so small it's just a few kilometers across. It is far denser than a pulsar, and its gravity is impossible to resist. Stray too close, and there is no turning back. Now we know why it's called a black hole. Its gravity is so intense that nothing, not even light, can escape. We watch as a stray asteroid, a lump of solid rock, approaches the point of no return, the event horizon. It stretches, pulled apart by the immense tidal forces, a process grimly known as spaghettification. It is dragged towards the gaping hole. Inside, there is no matter as we know it, no time, no space. All the known rules of physics collapse into a singularity. The asteroid is gone. The truth is, nobody really knows where. We are looking at the absolute limit of human understanding. There could be millions of these stellar mass black holes creeping silently around our galaxy. More, perhaps, than all the stars we can see. We wouldn't know they were there until it was too late. Like this star, which we see spiraling to its doom, disappearing down an invisible sinkhole. Who's to say we don't live inside a vast black hole right now? That our entire universe isn't just contained within another, larger universe. Sometimes it feels like the more we see, the less we know. But we do know our galaxy is more complex and more dangerous than we ever imagined. And we are still in our own galaxy, the Milky Way. The rest of the universe still lies ahead. The wonders, the dangers, the secrets, they're out there. But first, we have to find a way out of the Milky Way. 7,000 light years from home. Still, deep inside our own galaxy, we find ourselves in a cosmic forest, thick with trees. Each one so beautiful, so fascinating, it's impossible to look beyond them to see the bigger picture. We have to find a way through to reach the clearing at the galaxy's edge. Only then can we begin to understand where it and we all began. But faced with sights like this, it is hard to leave. This is the Pillars of Creation, part of the Eagle Nebula. Colossal glowing towers of dust and gas, like a gateway into the far galaxy. Both pillars are studded with tiny bulges, embryonic star systems, each one the size of our own solar system. It is another breathtaking monument to nature's astonishing creativity. But we have to ignore its captivating beauty, tear ourselves away, and carry on towards the edge of the galaxy. Dazzled by the Milky Way's beauty, we have strayed into a cosmic minefield. Like an explosion in slow motion, giant clouds of gas are bursting out of this star. This is a star millions of times brighter than our sun. The nuclear reactions that power it are becoming unstable. We are watching its death throes, and beyond it, an even bigger, even more dangerously unstable star. But this one is about to explode. And when a star this big dies, the explosion is 100 times more violent than a supernova. Somehow, we have stumbled into the most violent star death imaginable. A hypernova. The core has collapsed, instantly becoming a black hole. And that's the shockwave, surging through the star, ripping its outer layers into space. There is lethal gamma-ray radiation everywhere, enough to have a catastrophic effect on any planet unlucky enough to be nearby. It's possible that a mass extinction on Earth 450 million years ago was caused by the gamma-ray burst from one of these deadly hypernova that happen to be pointing in our direction. Frozen comets, scorched planets, white dwarfs, red giants, Earth. We pull back and back and back until they are all just tiny drops in a vast, swirling pool of white light. This is our home galaxy, the Milky Way. We wanted to know where we fit in. Here is our answer. All of human history, every civilization, past and present, everyone that has ever lived, the smallest bug, the highest mountain, all of it is contained on an invisible, insignificant speck. Our home is a minor planet of an insignificant star, in an obscure corner of a vast galaxy. If our sun disappeared right now, the galaxy as a whole wouldn't even notice. And yet, so far, we have found nowhere else we would rather live, nowhere else we could live. So far from home that we can truly appreciate it. But look at all these stars, hundreds of billions of them. Surely, one of them, more than one, must be capable of supporting life. Maybe here, in this dazzling swarm of stars, the Great Globular Cluster in Hercules. Back in the 1970s, astronomers sent a powerful radio message in this direction, detailing the structure of our DNA and showing the plan of our solar system. But it is so far from home that the message won't arrive for at least another 25,000 years. We haven't found alien life yet, but neither have we found any reason to believe it isn't out here somewhere. There's an equation, the Drake equation, devised to estimate the number of other advanced civilizations in our galaxy. And depending on the variables you plug in, the result is shocking. There should be millions of civilizations just in our galaxy. So where is everybody? This is the great silence, the Fermi paradox. Everything we have seen so far is inside the Milky Way. Now, here is our chance to see other galaxies, to glimpse the even bigger picture, and perhaps to answer the ultimate question: where does all of this come from? It's time to leave our home galaxy and enter intergalactic space. Beyond the Milky Way, through the vast, empty expanse between the galaxies. Against all the odds, we have made it to intergalactic space. Out here, there is no horizon in sight. Even the closest galaxies are hundreds of thousands of light-years away. We see the remains of smaller galaxies that have been ripped apart by the Milky Way's huge gravitational pull, their stars scattered through the nothingness. This is as close as the universe gets to a perfect vacuum. But even this isn't totally empty. There are thin wisps of gas, fine traces of dust, and something else, something mysterious, dark matter. So mysterious we can't see it, feel it, taste it, touch it, or even measure it directly. Yet it is so common, scientists believe it could make up over 90% of all the matter in the universe. If dark matter does exist, it means there is no such thing as empty space. Even out here, we are surrounded by a substance we can't comprehend. We only suspect it exists because of the strange gravitational hold it seems to exert on galaxies like this one. The Large Magellanic Cloud. This galaxy is orbiting the Milky Way, but it's moving so fast it should be spinning off into space. Yet something seems to be holding it here, something invisible and powerful. That something, astronomers believe, is dark matter. Stars, clusters of stars. But look at this. It's like a string of gleaming pearls, a fireball expanding out from what must have been a massive explosion. A supernova so bright that when the light from it reached Earth in 1987, It was visible with the naked eye. It was so violent, it triggered a string of nuclear reactions, forcing atoms together to create new, heavy elements, gold, silver, platinum, blasting them out into space. The gold in the ring on your finger was forged in a massive supernova like this, trillions of kilometers away, billions of years ago. Before we left home, the universe seemed separate from us. We were wrong. The universe is part of us, and we are part of the universe. It's a comforting thought to remember as we venture through this abyss. Further and further, faster and faster, the Andromeda Galaxy, 2.5 million light-years away, space towards us at nearly 1,000,000 kilometers an hour. We are seeing this galaxy as it was when our Aplic ancestors first walked across the African plains. In about 4 billion years, our two galaxies will collide and merge, a cosmic dance of creation and destruction. There is an order in this chaos, a pattern behind the infinite variety, an endless cycle of birth and death. It is a pattern woven through the vast fabric of space that binds each of these galaxies together. There are billions of galaxies in the visible universe, each with billions, even trillions, of stars. There are possibly more stars in the universe than there are grains of sand on all the beaches on Earth, and all these are just the stars that exist now. What about all the stars that have been and gone? All the stars being born and yet to be born, we are finally beginning to see the big picture, and it's bigger than we ever imagined. This galaxy, the huge Pinwheel Galaxy, is so far from Earth that if we were to send a message home now, it would take 27 million years to get there. Who knows whether our species, our planet, will still be around to receive it? We travel on, backward through time, past the point where the dinosaurs were wiped out. Light years from home, we are closing in on the edge of the universe, going back to the beginning of time. This isn't a galaxy. It is brighter than hundreds of galaxies put together, a blinding beam of energy bursting out for trillions of kilometers. Something this big, this bright, must be incredibly powerful. It looks like a quasar, the deadliest thing in the universe. If it is, then our journey could be over, just as the end is almost in sight. It is indeed a quasar, a swirling cauldron of superhot gas, more luminous than hundreds of galaxies. The source of this awesome power lies deep inside, at the heart of the beast, a heart of darkness, a supermassive black hole, as heavy as 1 billion suns. It is ripping apart whole stars, sucking their gases into a swirling accretion disk, heating them to incredible temperatures, and devouring them until they are nothing, lost forever from the visible universe. We have seen the worst the universe can throw at us, its most powerful and destructive forces. Now our path is clear. The very edge of the universe is almost within reach. But we still need to go further, faster, if we are to cross the final reaches of space and time. 8 billion light-years from home. More galaxies, but these look different. They are ragged, small, and close together. We are so far back in time that we are seeing these galaxies as they were before the Earth was even born. They are still young, still growing. We are getting closer to where and how it all began 12 billion years ago. Look at the galaxies. Now, they are more like primitive plankton floating in a vast, dark ocean. It's magical. Clouds of dust and gas are dancing, forming shapes, merging to make embryonic galaxies. This is how our own galaxy was born. They're disappearing. We have gone back before the first stars were born into a cosmic dark age. And before that, light. We are almost there. This is it. We have made it. The edge of the observable universe. 130 billion trillion kilometers from home. 13.5 billion years ago. We are at the very instant of the Big Bang, the most violent, most creative moment in history. Everything that has ever happened follows from this single moment. Every religion, every culture has pondered it, but we still don't know what sparked this ultimate act of creation or why. This is where our journey ends and the universe begins, at the single most important moment in history, the beginning of history itself. An infinitely hot, infinitely small, infinitely dense point erupts. The Big Bang creates space, time, matter, and energy, our universe itself. First, it is the size of a subatomic particle, the tiniest fraction of a second later. In a period of exponential expansion called inflation, it becomes big enough to hold in the palm of your hand. Moments later, it's the size of the Earth. Today, the light from the Big Bang stretched and cooled over billions of years. Your TV aerial picks it up. You can see it as the static on an untuned television channel. A fraction of that snow on your screen is a direct message from the creation of the universe. We now go forwards through time. On our incredible journey, our sparks flying out from the Big Bang galaxies. Stars, planets, saw just debris from that initial formative explosion. We fly back through our galaxy, through our solar system, until we reach another cooling cinder, swirling in the afterglow of the Big Bang, the Earth. After a 260 billion trillion kilometer journey, we are back where we started, home. Only now can we really know it. Now we know our home is smaller, more fragile, and less significant than we ever imagined. We know it is destined to die, swallowed by a dying sun, but we shouldn't despair. We should rejoice. Outpost, we have managed to discover all of this, to unlock the secrets of the universe. We should celebrate our achievements, cherish our precious, fragile home, and enjoy our moment in the sun.